Hi, I'm Bill Livency, otherwise known as William I on this site, and I'm going to talk today about a comet called Neowise. This comet was seen in July of 2020, and it has an orbital period of 4,400 years. And what is its mean distance from the Sun? Well, its mean distance is something on the average of this, and this is very close and this is very far away, but we do know from Kepler's second law that the area swept out by an orbiting body at its slowest point and the area swept out at its fastest point, and in fact any other point in between during the same amount of time are equal. Therefore, A1 over delta t is equal to A2 over delta t. And what does that tell us? That tells us that we can do an average around a circle to get the correct answers on the average or the mean radius. We look at Newton's third law, and we see that we have G ms for the mass of the Sun times the mass of the comet divided by the radius from the Sun squared, and that's equal to mg at this average radius. M's cancel here so that we have just the gravitational constant of the Sun equal to G ms over r average squared. The average speed is equal to the average distance over the average time. Well, the time that we're talking about here is a full circle, so it'll go around over 8,800 years twice. So anyway, we can now do some work with the centripetal acceleration, which is equal to v squared over rs for a circular orbit, and 2 pi rs squared over the square of the period should give us some interesting things. Substituting in for v squared over rs, we end up with this this expression here, and rearranging some of the radius terms will simplify to r to the third s is equal to g ms times the period squared over 4 pi squared. We'll do the math. Check it out. Now, one thing you have to worry about here is the units. The time in years is not in seconds, and newtons in the G, Newton meters squared per kilogram squared, is in the mg. Well, it's in the Newton system, which is in seconds. 4,400 years is the same as 3.8 times 10 to the 7th hours times 3,600 seconds per hour, and that gives us 1.38 times 10 to the 11th seconds. The mass of the Sun is this number, which I got from online, and G is this number here, Newton meters squared per kilogram squared times 10 to the minus 11. That means that we can plug these numbers into this expression here, and we can take the cube root of it to get r. And I did it in 2 steps because it's a little hard to keep track of what you're doing. And so it's 5.23 times 10 to the 40th. Cube root of that is 3.74 meters times 10 to the 13th meters, which is equal to 3.74 times 10 to the 10th kilometers. Thank you.